Okay, this is the Metamorphic Rock Lab, and the warm-up you can see is how are metamorphic rocks formed. They're formed from heat and or pressure on a rock. Two types, foliated, banded, or non-foliated. And you're going to see examples of both of those in today's lab. All right, here we go. And I'm reading right off the pages that you should have taped into your notebook. Metamorphic Rock Lab Part 1, Lab Procedure / Questions. So far, you've studied two major rock groups, igneous and sedimentary. Now we're going to take a closer look at the last group, metamorphic rocks. Scientists learn about metamorphic rocks by comparing them to other rocks. You've learned in the last lab that sandstone is a sedimentary rock. It's a clastic sedimentary rock that you have an understanding on how it's formed. Now let's compare it to quartzite, a metamorphic rock, to better understand its formation. Number 1, carefully examine the surface of sandstone, rock 1. Rub your fingers across the surface and describe how it feels. Okay, these rocks should be out and they should be numbered on the gray desk in front of the classroom. If they're not, just let me know and I will get them for you. So pause the video and write down, how does sandstone feel? Okay, this is what you should have got. It feels rough, gritty, like sandpaper. Okay? It is important that you write down these answers as we go over this lab because these are the answers you're going to use to help you answer the questions that are part of the Metamorphic Rock Lab Google form for lab grade. Okay? Number 2, put 3 or 4 drops of water on the sandstone rock and observe the water drops carefully. What happened to the water drops? Explain. Okay, the water cups are over by the counter with the droppers. Grab one and use that. It says 3 or 4 drops. Just put one or two. That'll be sufficient. Pause the video and do that right now. Okay, what you should observe is that the water soaked into the rock. It soaked into the rock because all the airspace between the particles of sandstone rock. So just like in soil, we talked about sand having a lot of airspace between it that allows water to quickly go through it. That's what mainly makes up sandstone, is lots of sand. Sand has big sized particles, therefore lots of airspace, allows the water to soak right in. Number 3, now carefully examine the surface of quartzite. Rub your finger across the surface. Describe how it feels. Pause the video and do that now. Quartzite feels smoother, less gritty / sandy than sandstone. Okay. Some other classes, people said it feels a little bit greasy. I tend to agree with that. Now, place, it says 3 or 4, just do 1 or 2 drops on quartzite and observe that the water drops carefully. What happened? Explain. Oops. Do that now. What you should have observed is that water sat on top of the rock and didn't soak in. This happened because quartzite is a metamorphic rock that was once sandstone. Heat and pressure pushed the sediments and particle sizes together, making the rock more dense and less porous. Therefore, the water just sat on top of the rock. Okay, so sandstone, clastic sedimentary rock. Quartzite is a non-foliated, non-banded metamorphic rock. It formed when sandstone had exerted heat and or pressure on it, causing those particles to get squeezed and compacted closer together, therefore making it harder, denser rock, making it a lot harder for the water to soak into the rock. Okay? All right. Sometimes we can use familiar materials to learn about the earth. Let's try using a piece of bread to better understand how metamorphic rocks form. Examine the surface of a piece of bread. Lightly rub your finger across the surface. How does the bread feel? So come and see me and I will give you a piece of bread. Rub your fingers across it. Don't put any pressure on it and describe how it feels. Pause the video and do that now. Okay, well, if you feel the surface of bread, it feels rough. If you look at it, it appears very porous. Okay, lots of holes in it. Okay. All right. I keep messing up the video here. Number 6, place. Just do 2 or 3 drops of water on the bread and carefully observe what happens. Okay. And I want you to write that in for number 6. By the way, as I go over this, I'm asking you to write this stuff down. Write it. I want you to write it in your notebook on the first piece of blank paper that you come to. Okay? And number them. Number this number 6. All right. Well, what you should observe is that, well, the water soaked right into the bread because it has lots of pores, lots of airspace that allows this to happen. Now, come and get a second piece of bread from me. Take the second piece of bread and press it into a dough ball as tightly as you can. Rub your finger across the surface of the bread. How does it feel? You should notice that it feels smooth, smoother than the first piece, okay? Dough ball feels smoother than the first piece. Now, I want you to press that bread. It says between your hands to flatten it. I just want you to take your thumb and flatten it on the surface of the table. Now put 1 drop of water on it and observe what happens. Write that in here. Or write that for number 8. What happened to the water drops? Explain. Well, if you observed it correctly, the water just sat on top of the bread. It didn't, and then it slowly soaked in. Why? Because you've compacted those bread particles closer together. You've metamorphosized that piece of bread, making it more dense. Okay? How has the second piece of bread changed? The bread was compacted through heat and pressure of your hand. What effect did this have on the spaces in the bread? Well, it caused them to be eliminated, become smaller. They became closer together. How does this affect the properties of the bread? Again, it made the bread more dense. Matter is more compacted. Particles are closer together. Number 10, which piece of bread has properties similar to sandstone? That would be the first piece of bread, the non-dough ball. Which piece of bread has properties similar to quartzites? That would be the dough ball. Okay, so you've changed the piece of bread by pressing it together. On Earth, rocks can also be changed. Very high temperatures deep in the crust help change rocks. Rocks buried deep in the crust are also pressed and squeezed together. This helps change them. When sandstone is pressed together, it forms quartzite. The sandstone becomes a solid mass of quartz. Change is the name of the game. Meta means change. This is important. Morph means form. Put them together, and what do you have? Metamorphic means changed form. Now let's take a closer look at 2 more rocks. Granite is an igneous rock you've become familiar with from the previous lab. By this time, we're also going to take a closer second look at gneiss, which is a metamorphic rock. Both granite and gneiss are made from the same minerals, biotite mica, quartz, and feldspar. The biotite mica is the black you see, quartz is the white, and feldspar is the pink. Examine granite rock number 3 and gneiss rock number 4. Carefully look at the way quartz and biotite is arranged in granite rock. Look at the way the same 2 minerals are arranged in gneiss rock. How are granite and gneiss the same? Pause the video and answer that question. Well, they have similar colors, which means they have similar minerals, okay? How are they different? Pause the video and answer the question. Well, they're different because granite and gneiss have the colors arranged in the rocks differently. Granite has the minerals throughout the rock, therefore it's speckled with colors. Gneiss, the minerals are banded together or foliated. You see the layers. Explain what could have happened to gneiss to make it appear this way. Well, heat and pressure turned granite into gneiss. So heat and pressure was put on the granite. The rock underwent metamorphism by the minerals kind of melting, becoming liquefied. They separate out by density. And when you put that pressure on it, that causes that banding. They get squeezed together, and therefore you have the rock gneiss. Okay, now I would make sure you have all these answered correctly. You have them written down in your notebook. You can use this information to help you answer the Metamorphic Rock Lab Google form, which is posted on Google Classroom under Metamorphic Rock Lab analysis questions. Okay, please make sure you do that. That's what you're being graded on. All right, have a great rest of your day.